Thanks very much. Perhaps I can just correct you. It's what are metadata? The number of people who don't know that data is actually plural. Okay, so this is, I can keep this fairly short as coffee breaks coming up, and because this is a new program. It's only been running since January when we had our Oversight Committee meeting. But really what I want to do today is just set out what the objectives of this is going to be. So just before I get into what the task forces are going to do, it is interesting to know what actually metadata are. I'm sure most people in the audience know what metadata are, but we also need to think about why we need them. They're obviously a rich set of descriptive information that's necessary to archive, store, share and reuse data. They actually they're of equal importance to the primary data because without them you can't really use the primary data. And they define a whole range of conditions and methods that we use for acquisition, such as the device that was used, the study protocol, the parameters for the experiment, and subject and patient information. But they also include, for analysed data, the statistical procedures that we use, because again, if you're looking at results, they're useless if you don't actually understand how they were derived. So the key factor is that shared data is of very little value if they cannot be understood. And the great challenge for us is to create useful databases, and extending the longevity of data is the quality of the metadata that actually goes alongside the data itself. So the overall aim of the project is to develop some generic minimal requirements, in other words, some standards that allow for reporting of metadata and for the reusing neuroscience data and databases. And the sort of global questions that the program is going to address is how should metadata be organized and made accessible with the primary data? How should the metadata be structured to handle the large diversity that they come in some cases the complexity of them, and how can the databases adapt to handle new forms of metadata as new methods and applications emerge? Now these are really quite challenging questions, and within the framework of the overall project, our specific objective is to establish the minimal requirements for metadata associated in two specific domains. Now we've heard a lot about anatomy in the last two programs. The program is going to largely be focusing on functional activity, so neuroimaging and functional neuroimaging databases are going to be one area, and the other is on electrophysiology, which might include EEG. So we hope at the end of, once the program is up and running, some of the outcomes are going to be practical and feasible standards that are established that facilitate the sharing and reuse of data. Now, as I say, it's a new program. The Oversight Committee met in January. Here's a list of the people which came from across a whole range of areas and from different nodes across the world. And we sat down and we actually asked the question, really, what are the effective barriers, or the barriers for effective data sharing? And if you think about the life cycle of data sharing, it really starts with the point of the data originator and asking the question, really, are you willing to take the time to prepare your data for sharing? And that's going to be a real block if people are not willing or are unable to spend the time to prepare their data, then sharing can't take place. There's also an important question about, is there somewhere where you can actually put your data for sharing? Now, we're not actually going to address the issue of the infrastructure that's required for data sharing. Hopefully there's enough out there that we can work with existing structures to do that. But a key question is, once you've shared it, can I actually read your data if you shared it with me? And if so, can I actually understand it? So can I understand how it was acquired, how it was analysed? And not just myself now, whilst maybe you and I are still around and you're sharing the data with me, but sometime in the future, in 10, 20, 30, 50 years, will it still be possible to understand those data? Now, there's some major questions involved here, and of course metadata is absolutely essential to this, but it became apparent to us in the program that in fact we're not just talking about metadata, we're actually talking about the whole pipeline for data sharing. So although it started off as the program on standards of in metadata, we're now changing, we're now calling ourselves the program on data sharing. So there are actually problems with implementing metadata standards. I think we can all accept that the process needs to be improved, and we can all think about the perfect world. But unfortunately, the issue comes that detailed database schema that have high definitions of metadata often have a very large overhead and can be a burden to users, and this reduces the incentive to contribute. So that very first step in the data sharing, are you prepared to prepare your data for sharing, can actually be a block by providing people with the resource or the framework in which they can describe their metadata. So we also need to ensure that in preparing standards, we don't produce standards that jeopardize the objectives of particular projects. So people describe their data in a particular way because it's important for their project. But if we start implementing metadata standards, it may actually jeopardize the way they're doing their work. And the last point is here, it's not possible to define all the metadata needed to describe every single condition of an experiment in sufficient detail. Therefore, in fact, it's likely that we're going to fall short of expectation, certainly for some individuals. And that's why metadata standards are important. And although we started off addressing the question of minimal metadata, we need to think about what's the sufficient metadata in order that people can understand. So we have actually established two task forces, as mentioned by Jan. There's a neuroimaging data sharing task force, and that's being led by J.B. Bolin and David Kennedy. And there's going to be an electrophysiology data sharing task force led by Thomas Wachler and Fritz Sommer. So just looking at the first of these, the neuroimaging data sharing task force, if we think about the pipeline that's involved in sharing neuroimaging data, and we're specifically focusing on MR imaging, there's a question at the local level about the equipment that's used to capture the data. And unfortunately, that's fairly limited number of equipment manufacturers. The processing, however, and the analysis pipeline is somewhat diverse, but again, there are a number of well-established pipelines for taking MR data. And there are ways of capturing some related measures, particularly clinical data related to the subject. All that information needs to be held locally, but if it's going to be shared, we need to think about how that interacts with a database server, whether or not the upload and capture of the information needs to be manual or can be automated. And then we think about the actual sociological processes of data sharing and publication that comes out of that server. But we're interested in this process here about how do we get data into a server in a usable format. Oops, sorry. Let me just flick through these. So in terms of the actual data that's required, one of the people on from LONI program has already produced a list of the sort of data that's required, the minimal information that was required for specifying an experiment. And this is a list of the sort of data that would be required to be captured locally. So not only the raw data and full descriptions of the acquisition, but also what the processed data looks like, full subject, demographic and diagnostic details, the experimental design, annotations relating to the mapping, essential data processing protocols and workflows. And all of this information somehow needs to be gathered together into the database in order that the information becomes useful. So the initial objectives of the neuroimaging data sharing task force are to look at the way in which all those data can be wrapped together in one way. And they're going to start with some sample data from public data repositories, for example, the 1000 functional connectome, and evaluate the current metadata standards. For example, XSEED would be the one of preference at the moment, but there are a number of other candidate wrapping formats that need to be tested to look at interoperability with existing databases. Once a decision is made about what the metadata standard is going to be, there'll be a need to develop ways in which we can facilitate the capture of that information. And a proposal is that the task force will work on developing a tool for local neuroimaging data and metadata management, including particularly automated metadata capture from acquisition equipment. Now, in doing this, we were able to implement a standardized metadata schema for it, but the important thing here is trying to make it as automated as possible in order to reduce that threshold for people to contribute their data. And the final objective of this group is to work with the existing analysis software companies and people who are developing software to ensure that the metadata of the processed images are collected and stored in a standardized way alongside the data itself and the results. So the second task force, the electrophysiology data sharing task force, if we look at this process for them, there are a couple of some major differences compared to the neuroimaging, and that is that the data acquisition and the equipment that's used is extremely diverse. The methodology used for electrophysiology is far more diverse than it is for MR imaging. And the type of data that exists and the processing and analysis of that is again far more diverse than exists for MR. So one of the challenges for the electrophysiology task force is firstly to identify the community of users and evaluate the existing metadata schemas and databases in order to define the potential scope for metadata definitions. But then to develop minimal metadata schemas to describe those experimental details, and particularly to work alongside existing initiatives. And we've just heard from Marianne about PONS and Neurolex. These are going to be important for describing certain areas of the metadata, and to ensure the data are collected and stored in a standardized way. And similar to the other task force, we do need to work with major equipment and software analysis manufacturers to develop methods for data capture and interoperability. Unfortunately, there have been some initiatives previously. There's a Neuroshare initiative that looked at the interchange of data for electrophysiology, and would like to work with them to try and promote that activity. So just to conclude then, over the coming years, how will the programme make this data sharing pipeline feasible? How will they improve data sharing? Well, really in three main areas. One is the question at the local level about developing up automated and standardised methods for metadata capture. And the second is to develop methods to ensure interoperability, both with databases and between databases. And thirdly, to develop standardized and comprehensive metadata schemas so the recipients of these data can make most use out of them. Thank you very much indeed.
Thanks very much for this update, and then questions again?
That was terrific. One point that perhaps it was in there and I missed it because there was so much useful information, but there's another aspect of the data sharing challenge, which is to get the relevant metadata into publications in a machine-readable and extractable way. And has your group discussed that, included it in your agenda?
Indeed. If you, so publication was one of the issues here about interacting with the database. I would see the publication as actually being a data user, much in the same way as somebody who works in the laboratory and actually taking the data. The publishing houses are actually going to become data users in the long run.
Good.
Colin, I think it's fair to say that most of the sharing of neuroimaging type data has been for meta-analyses, so actually looking at results as in activation coordinates. And of course there's a group which has a philosophy that that's really the most productive way forward now, and given the difficulties of describing functional imaging studies, that it's probably likely to be for some time the only productive way forward for sharing. I just wondered if you had an opinion or a view about the relative merits of the sort of bottom-up data sharing versus results and meta-analyses type of sharing?
Okay, well, the key element there, fine, everybody's sharing the results, but at the moment we don't understand often how we get to the results. So one of the key elements of the task force is actually to look at the pipeline that's been used for processing and to map that out and look at provenance trails for how the data actually, how you arrived at the data. Because comparing between laboratories who may be using quite different analysis pipelines actually becomes, in some respects, quite meaningless. So I think that's a first issue. Sharing of the raw data, I think, is your question. I mean, that's important because you can reanalyze in different ways, and I would guess we're going to have to look at that. I don't know whether, is JB here? At the back there. Do you want to comment? as task force lead?
So there will be no official statements on that.
Oh, well, okay. His answer looks like mine.
And one of the things I think is really important, we don't have a good way of reproducing the results at the moment. And my guess is that in neuroimaging, for instance, a lot of the published data is probably wrong. It's quite a complex process to go from the data to the results. And there's a fair chance that there's a lot of mistake being done on the so I mean, getting to science is getting to how to reproduce things, and getting to reproduce things, you need to be able to get back to the data. You need to be able at some stage to get back to the analysis. So that's probably one of the driving force of the thing, is to how do you get to reproduce things. Okay. And then obviously being able to then analyze more and and go deeper, and that's also very attractive. But
Okay, thank you very much, and thanks to all the speakers.